Hello students, welcome to Educate. Let's discuss the second chapter of class 12th, that is electrochemistry. Let's see. First of all, what is electrochemistry? In the examination, question will not ask what is electrochemistry, but you should know. So, first of all, electrochemistry is the branch of chemistry which deals about the relationship between electricity and chemical reactions. As the name indicates, electrochemistry, that means the branch of chemistry which deals about the relationship between electricity and chemical reactions. That is called electrochemistry. In electrochemistry, first of all, we will have to discuss about the cell, that is electrolytic cell and electrochemical cell. Okay, let's see. This one here, galvanic cell or voltaic cell. About this one we will discuss. Galvanic cell or voltaic cells are the cells which convert electricity into, which converts chemical reactions into electricity. Galvanic cell or voltaic cell will convert chemical reactions into electricity. That means the chemical reactions will take place, and due to that chemical reactions, there will be production of electricity in galvanic cell or in voltaic cell. How does it work? Let's see. Here, this one is the diagram of galvanic cell or voltaic cell. This diagram. How it works? Listen here. And this one is the vessels in which there will be Zn2 plus and SO4 2 minus. That means ZnSO4 has been taken, which dissociate into Zn2 plus and SO4 2 minus ions. And this is another vessel in which the CuSO4 electrolyte has been taken. The electrolyte CuSO4 has been taken. That means the compound CuSO4 taken here. Electrolyte means the substance which dissociate in ions, and that will be responsible for the production of electricity. So let's see here in this vessel the electrolyte CuSO4 has been taken. So CuSO4 will dissociate into Cu2 plus and SO4 2 minus. Both the vessels has been connected through a U-tube which is called salt bridge. Usually inside this salt bridge KCl has been taken, that will dissociate into K plus and Cl minus. This U-tube is called salt bridge. In this vessel, ZnSO4, the electrolyte ZnSO4 has been taken and the rod zinc has been dipped. In this vessel, the electrolyte CuSO4 has been taken and the rod copper has been dipped. Now, how does that work? Let's see how there will be functions of this galvanic cell or the voltaic cell. Among zinc and copper, zinc have greater tendency to loosen the electron. Among zinc and copper has greater tendency to loosen the electron compared to that of copper. Which element will have greater tendency to loosen the electron and less tendency to loosen the electron? That's depend on a number of factors like ionization enthalpy, lattice enthalpy, enthalpy of crystallization, and so on. So here only you should know that among zinc and copper, zinc has greater tendency to loosen the electron when both zinc and copper exist in solid phase. Here, zinc rod and copper rod, that is existing in solid phase. So, zinc have greater tendency to loosen the electron. Now, let's see what happened here. From this rod, the zinc atom loosen the electron. So, zinc atom here which exists in solid phase, that loosen the electron. So, that zinc atom will convert it to zinc ion, that means Zn 2 plus and 2 electron. This zinc ion will go inside this solution. From this, at this zinc rod, the zinc atom will loosen the electron, converts into zinc ion, and that will enter inside the solution. And this rod, 2 electron, that will left at this rod. Okay, through this rod, the electron will flow. Through this one, electron will be there, and this electron will flow and come to this rod. Inside this solution, there is Cu2 plus ion and SO4 2 minus ion. So there is full of electron. So copper ion get attracted towards this rod. Copper ion get attracted towards this rod. So Cu2 plus, which is inside the solution, that will get 2 electron and convert it to copper atom. Copper atom, and that will deposit at this rod. The copper atom will deposit at this rod. Okay, in the same way here. So that happened here. Now sulfate atom. During that course, there is sulfate here. During this course, the amount of cation here will be more and anion will be less. Since cation enter inside the solution in this vessel, the cation entered inside the solution, and here the cation get deposited at this rod. So the amount of sulfate ion, that means anion, will decrease here. The relative number of sulfate ion, that means anion, will become here less compared to that of cation, and here the amount of sulfate ion with respect to cation, that will be more. So this sulfate ion will enter through this salt bridge, come to this solution. So there will be movement of negative charge from this rod to that rod and from this solution to this solution. As a result, this circuit will get complete. This circuit will get complete. Negative charge moves from this rod to this rod, and from here this vessel to this vessel through this salt bridge. Now electron moves from this one here, act as anode. This rod act as anode, and this will act as cathode. It is anode here, it is cathode. Now the negative charge flow from this anode to cathode, and current is defined as the movement of positive charge. So negative charge is flowing this side, so direction of current will be from this one to this one. Okay, that was how that work. In the examination, question will ask, write about galvanic cell or the voltaic cell. Then what you will have to do to get the full marks? First of all, you will have to draw the diagram. Rough diagram you will have to draw. That means if your diagram will be too much beautiful or not beautiful, doesn't matter. You will have to just show this diagram. Now, then after you will have to write the reaction at anode. Reaction at anode, zinc atom which is in solid phase that convert into zinc ion and 2 electron. Then after reaction at cathode, copper, here zinc ion that will be in aqueous state. Now copper ion which is in aqueous state, that will gain 2 electron and convert into copper atom which will exist in solid phase. This one here. Now what happened? The current will flow from cathode to anode. Okay. Now next point, one point is that sulfate ion SO4 2 minus will flow from cathode to anode through salt bridge. That amount only you will have to write and you will get full marks. Now let's see representation of cell. How you will represent this cell? Representation of cell. Representation of cell. What is here? Here zinc atom is converted into zinc ion. So you write here this one, here aqueous state, and during the question on the place of this aqueous state, concentration of zinc ion will be written, and then after double slash, then Cu2 plus which is in aqueous state, that will convert it to copper atom in solid state. That is representation of cell. What is the EMF of the cell? This EMF of the cell. EMF of the cell, that will be electrode potential of this cathode minus electrode potential of anode. So EMF of the cell here, EMF of cell, that will be equal to EMF of cathode minus EMF of anode. Here cathode here is copper, so that will be EMF of Cu2 plus slash Cu, this one minus EMF of Zn2 plus slash zinc. That is okay. So that is representation of cell. So we have discussed here the galvanic cell or the voltaic cell, in which the zinc has acted as anode and copper has acted as cathode. Now let's see a standard EMF of the cell. A standard EMF of the cell. To calculate a standard like that, when you will have to find out the 1 kg apple, then what's the shopkeeper do? The shopkeeper takes, when you will have to purchase 1 kg apple, so the shopkeeper will do at a balance here, that will be at one pan, the shopkeeper will take a weight, fixed weight, that is 1 kg. This fixed weight has been universally accepted as 1 kg. And on the another pan, the shopkeeper puts apples, and then after he compare, if this line, this rod will be straight, that means this weight will be equal to this weight, and its weight is 1 kg, so its weight will be also 1 kg. Since the standard he have taken here, this fixed weight he have kept, that is 1 kg, so and its weight is equal to the weight of apples, so the weight of apples will be also 1 kg. So during that one case, a standard has been taken. In the same way, when we calculate the atomic weight of any element, then we consider the atomic weight of carbon as 12, and with the atoms of carbon 12, we compare the weight of atoms of different elements. So in that case, during the calculation of atomic weight, carbon 12 considered as a standard. Here in this case, in case of galvanic cells or a standard EMF, we take hydrogen as a standard. We take hydrogen electrode as a standard, and we consider the standard electrode potential of hydrogen as 0. A standard electrode potential of hydrogen as 0. Okay. One point also keep in the mind here. Just I am going on the this one diagram. What is happening here? No need to mug up. What is happening here? At anode, there is zinc atom is converting into zinc ion. Loss of electron is oxidation. So at anode, oxidation takes place. Oxidation takes place, and at anode, what is happening? Cu2 plus is gaining 2 electron, and there is formation of copper atom. So at the cathode, there is a gain of electron, and gain of electron is called reduction. So reduction takes place at cathode. So at cathode there will be reduction, and at anode there will be oxidation. And this concept, keep in the mind, that may ask in NEET examination as well as mostly in NEET examination, and there is also chances of asking that question in IIT main. Okay, so always keep in the mind that at anode oxidation takes place, and at cathode reduction takes place. Okay, so now about the standard here, when we will have to calculate the standard electrode potential. A standard electrode potential when we will have to calculate. During that course, we take hydrogen electrode as a standard, and we consider the standard electrode potential of hydrogen as 0. Now, how to find out the electrode potential of zinc and copper? Let's see here. First of all, let's discuss about hydrogen electrode. How is that? Measurement of electrode potential. In that one, we measure by the hydrogen electrode, and a standard electrode potential of hydrogen is considered as 0. What's the structure? What's the construction of this hydrogen electrode? There is a vessel. In that vessel, 1 molar HCl has been taken. In this vessel, 1 molar HCl has been taken. This solution is, concentration of this solution is 1 molar HCl. So HCl, that will dissociate into H plus and Cl minus. So this, there will be, when you will take 1 molar HCl solution, then the concentration of H plus ion will be also 1 molar, and that of Cl will be also 1 molar. We will have to consider about H plus. Now hydrogen is taken as a standard. So the electrode to which we will the electrode of which we will have to measure the standard electrode potential, we will join this hydrogen electrode to that electrode. As for example, let's see, we will have to calculate the standard electrode potential of zinc. So to this vessel, we will take a vessel in which we will take zinc rod, and here the hydrogen electrode. Here we will take hydrogen electrode. In this vessel, we will take here 1 molar ZnSO4 solution. ZnSO4 solution. That means molarity of ZnSO4 will be 1 molar. In hydrogen electrode, we have taken 1 molar HCl solution. Now, what happened? The zinc atom here, that will lose the electron. Zinc atom here, it is existing in solid phase. Now it will lose the electron, so that become Zn2 plus and 2 electron here. That electron will be absorbed, will flow from this, that means anode, to the electrode hydrogen. In this hydrogen electrode, there will be hydrogen gas will pass through these pores, which will be at 1 bar pressure. Here the hydrogen gas will pass, here also given the hydrogen gas will pass at 1 bar pressure. Now let's see, when we have connected the zinc rod to this hydrogen electrode, then the zinc atom of this rod, that will loosen to electron and convert into Zn2 plus. The Zn2 plus will enter inside the solution. The zinc as Zn2 plus will enter inside this solution, and the lost electron that will come to this electrode. Now inside this solution there is H plus and Cl minus. So H plus ion present inside this solution, that will get, this one here is platinum foil. Here is platinum foil. Here, finally divided platinum coated on platinum foil. So the H plus ion get attracted towards this platinum foil. This H plus ion will gain 1 electron, and that will convert into hydrogen atom. The 2 hydrogen atom will combine together and will form H2. So here hydrogen H plus ion has gained the electron. Here is at cathode, there is gain of electron. So we can say that at cathode the reduction takes place, since the gain of electron considers as reduction and the loss of electron considers as oxidation. So at anode here oxidation takes place at cathode. Now when we have connected the zinc rod to the hydrogen electrode, then the zinc has converted into zinc ion, and here movement of current will be from the hydrogen to the anode zinc. So the direction of current will inform you that the electrode to which you have connected through the hydrogen electrode, that will get oxidized or that will get reduced. Okay, so now how to calculate? And this voltmeter gives you the information about the potential difference between hydrogen electrode and the zinc electrode. The reading of this voltmeter is 0.76 volt. Okay, the reading when experiment has been done, then it has been observed that the reading of this voltmeter was 0.76 volt. Now EMF of cell, that will be equal to a standard electrode potential of cathode. So here is hydrogen minus standard electrode potential. A standard here we have taken. Why? Because the concentration of electrolyte of zinc is 1 molar and one of the electrode is hydrogen. That's why we tell a standard EMF of the cell, that is a standard electrode potential of hydrogen minus a standard electrode potential of zinc. This one. Okay. So EMF of the cell has been observed as 0.76 volt. So 0.76 volt. That will be equal to, now a standard electrode potential of hydrogen has been considered as 0. So 0.76 volt, that will be equal to 0 minus 0.76 volt. 0 minus, that will be here, here will be 0.76 volt will be equal to 0.76 volt will be equal to 0 minus a standard electrode potential of Zn2 plus slash zinc. So a standard electrode potential of Zn2 plus slash zinc will be equal to, here negative sign will come this side, 0.76 volt. Okay guys, 2 points you keep in the mind. You have observed that or not, I don't know, but I am telling you 2 points you keep in your mind, that whenever we tell electrode potential means reduction potential. Here electrode potential of hydrogen means when H plus converted into H2. Electrode potential of zinc, so when Zn2 plus converted into zinc. Keep in the mind that will be utilized in D block elements also and in this chapter later on also. So keep in the mind that a standard electrode potential means reduction potential. A standard electrode potential, when we tell, that means we are telling about the capability to gain the electron. Okay. So here when the taken electrode has been oxidized, that means when zinc have the greater tendency to oxidize, when the zinc have here, the zinc have greater tendency to get oxidized compared to that of hydrogen. During that course, the standard electrode potential will be negative. If any element have the standard electrode potential negative, that means that element will have greater tendency to get oxidized compared to that of hydrogen. Okay, so that is here. So now in the same way we compare the standard electrode potential of copper. Right now we have discussed the standard electrode potential of zinc. In the same way we will calculate the standard electrode potential of copper. So let's see here how to do. In a vessel we will take here CuSO4 solution and we'll dip the copper rod. Copper rod we have dipped. Here we will take, inside this one we will take CuSO4 solution 1 molar, we will take 1 molar CuSO4 solution. 1 molar CuSO4 solution. 1 molar CuSO4 solution. And here the hydrogen electrode we will take. Here is hydrogen. Here copper rod, so that is a knot that is connected through voltmeter and that will be passed through this one. Here is platinum foil. The hydrogen gas will pass through here at 1 bar pressure. Here 1 molar HCl solution we will take. Hydrogen gas passed here, and both the electrode will be connected through the salt bridge. Here 1 molar HCl, so that will dissociate into here H plus and Cl minus, H plus and Cl minus, and here CuSO4 we have taken, so there will be Cu2 plus and SO4 2 minus. Among copper and hydrogen, the hydrogen has greater tendency to loosen the electron. Among hydrogen and copper, the hydrogen has greater tendency to loosen the electron. So what happened? Inside this tube there is hydrogen H2. This hydrogen will loosen the electron, so there will be formation of 2 moles of H plus ion and 1 electron. So what happened? The 2 H plus ion and 1 electron. The H plus ion will enter inside the solution. The H plus ion, here the hydrogen gas available, this hydrogen gas will loosen the electron, will convert it to 2H plus ion and that electron. So here 2 electron. So here the H plus ion will enter inside the solution. Okay, so lost electron here, this electron will flow from the hydrogen to this one, to this copper. So electron will flow in this direction. So direction of current will be from copper to hydrogen. Since negative charge is flowing from hydrogen to the towards the copper, that's why current, the direction of current will be from copper to hydrogen. Okay, and what happened here? So when electron comes to this rod, the Cu2 plus present inside the solution, that will get attracted towards this copper rod, and this Cu2 plus will gain 2 electron and will convert into copper atom. So here Cu2 plus initially in aqueous state, and after gaining the electron, that comes in solid phase. Okay, and so direction of current informs you that the taken electrode get oxidized or reduced, or the taken electrode will act as cathode or anode. Here the copper is gaining the electron, so copper here has acted as cathode and hydrogen has acted as anode. This voltmeter, reading of the voltmeter has been observed as 0.34 volt. The reading of voltmeter is 0.34 volt. You know EMF of the cell. So here a standard EMF, because the concentration of CuSO4 here is 1 molar. Concentration of CuSO4 has been taken as 1 molar, and one of the electrode is taken of hydrogen. That's why we consider as standard. So a standard EMF of the cell, that will be equal to a standard electrode potential of cathode minus a standard EMF of the cell will be equal to a standard EMF of cathode minus a standard EMF of anode. Here EMF of the cell has been observed as 0.34 volt. So 0.34 volt, that will be equal to a standard electrode potential of cathode. Here the direction of current is from hydrogen to copper. So copper here has acted as cathode. So here a standard electrode potential of Cu2 plus slash Cu minus a standard electrode potential of H plus slash H2. So here standard electrode potential of hydrogen is 0. So 0.34 volt will be equal to standard electrode potential of Cu2 plus slash Cu minus 0. So that means the standard electrode potential of Cu2 plus slash Cu is 0.34 volt. Now guys, keep in the mind, here the standard electrode potential of copper has not become negative, it be positive. So if the standard electrode potential of a particular electrode will be positive, that means the taken electrode will have greater tendency to gain the electron. That means the taken electrode will have greater tendency to get reduced compared to that of hydrogen. Previously, we have calculated the standard electrode potential of zinc, and we find out that the standard electrode potential of zinc was negative, and that was indicating that zinc have greater tendency to get oxidized compared to that of hydrogen. So, how we calculate the standard electrode potential of any element that we has washed out? That was, sometimes question also asks in 12th board examination, write about a standard electrode potential of hydrogen. So what you will do? First of all, you will have to draw this diagram. Draw the diagram firstly, that is construction. Then after write here, when hydrogen will get oxidized, then what happened? The hydrogen present inside the tube will loosen the electron and will enter inside the solution. The hydrogen present in the tube will lose the electron. The hydrogen present inside the tube will lose the electron and will enter inside the solution, So reaction, what will happen? Reaction will be what? H2 here, that will lose the electron, 2 moles of H plus ion and 2 electron. That will be. And second one, when hydrogen will get reduced, then what happen? The H plus ion present inside the solution, will gain the electron. So here 2 moles of H plus ion will gain 2 electron and there will be formation of H2. 2 marks question will ask, that means usually 2 marks question asks, write about hydrogen electrode. So to get 2 marks, firstly you will have to draw this diagram and then we'll have to write when hydrogen will get oxidized, then what will happen? H2 will convert into 2 moles of H plus ion and 2 electron. And when hydrogen will have to reduce, then what happen? The H plus ion present inside the solution will gain the electron and that will the reaction. Okay? Very simple it is. Now, that was about the standard electrode potential. One point, write that when the standard electrode potential, when the standard electrode potential will be negative, that will indicate that the taken electrode will have greater tendency to get oxidized. Okay? And when the standard electrode potential of the electrode will be positive, that will indicate that the taken electrode will have greater tendency to get reduced compared to that of hydrogen. Okay, one point also you keep in the mind, more negative be the electrode potential. More negative be the electrode potential, or more negative be the standard electrode potential, then more be the tendency to get oxidized. If there is two element of which the standard electrode potential of which element will have greater negative value of standard electrode potential, that element will have greater tendency to get oxidized. Actually, the electrode potential means reduction potential. Electrode potential means reduction potential. Okay. Now let's see, proceed here. So this one we have already discussed. These are the just like the story parts. Half cell reaction, what is that? We did. Now let's see about this question. How would you determine the standard electrode potential of the system Mg2 plus / Mg? About that one, very simple. Can you do this question or not? Simple here. You magnesium rod you will take, a vessel here, the zinc rod here, MgSO4 solution you will take, Mg, which will dissociate into Mg2 plus and SO4 2 minus. Here you will take hydrogen electrode, here you will take, and that will connect to this one. Here hydrogen gas will pass at 1 bar pressure. Here voltmeter will get connected. Here the voltmeter will be connected. Here the reading of voltmeter will be 0.76 volt. So what happened here? This one connected. The direction of current will be from hydrogen to magnesium. That means magnesium will act as the direction of current will be from hydrogen to the magnesium. Current direction is from hydrogen to magnesium. That means magnesium here is getting oxidized. That means magnesium here is acting as anode and hydrogen acted as cathode. So standard EMF of the cell, that will be equal to standard electrode potential of cathode, means here H plus / H2 minus standard electrode potential of anode. Anode means Mg2 plus Mg. Here EMF of the cell has been considered as 0.76. So here 0.76 volt. In the reading of this voltmeter is 0.76. So standard EMF of the cell is 0.76 volt. So that will be equal to here 0 minus standard electrode potential of magnesium. So standard electrode potential of magnesium will be minus 0.76 volt. So by this method you can calculate the standard electrode potential of magnesium. Okay. Then after this, can you store copper sulfate solution in a zinc pot? So here is a zinc pot here. Suppose this is a zinc pot. This pot is of zinc. In that solution, in that pot, if you will keep CuSO4 solution, so CuSO4 will dissociate into Cu2 plus and SO4 2 minus. Now among copper and zinc, zinc has greater tendency to loosen the electron. So the zinc atom of this zinc vessel that will lose the electron, will convert it to Zn2 plus and 2 electron. So here this zinc atom present at this vessel, that will convert it to Zn2 plus, and that Zn2 plus will enter inside the solution, and here that will be full of electron. The Cu2 plus will get the 2 electron, Cu2 plus will get 2 electron, will convert into copper atom. So when that will get converted into copper atom, that will be precipitated out. So here zinc converted Zn2 plus and the Zn2 plus entered inside the solution, while the copper Cu2 plus gain the electron and get precipitated here. So when this process will continue, then the vessel will become porous. So after a certain time period, this zinc vessels will become porous, and hence you cannot store the CuSO4 solution inside the CuSO4 solution inside the zinc pot. It is just like that. If a vessel is made up of a mud and you have stored water, so what will happen? Mud will get entered inside the water. Mud will enter inside the water, and this vessel will become porous. So that's the reason here we cannot store CuSO4 solution in zinc pot. Then after this, construct the table of standard electrode potentials and suggest 3 substances that can oxidize ferrous ions into suitable conditions. So let's see here, consult the standard electrode potential. So let's see, consult the standard electrode potential. This is the table of standard electrode potential. Here, from here, the standard electrode potential here is hydrogen. A standard electrode potential of hydrogen here, that is given 0. Here 0. Below to that one here, as you move down here, then the standard electrode potential became negative, and that's negative value is increasing. Watch out here, lithium. Lithium is have very high negative value. The standard electrode potential of lithium is highly negative. That means lithium have too much tendency to get oxidized. That means oxidation potential of lithium is highest among this one, and the reduction potential is lowest. Reduction potential means tendency to get reduced, and when greater be the value of electrode potential, more be the tendency to get reduced. So less be the tendency to get oxidized. Keep in the mind, a standard electrode potential will be high. That means when the magnitude of a standard electrode potential of any element will be high, that means their tendency to get reduced will be high. And if the standard electrode potential of any element will be negative, that means if the standard electrode potential of any element will be less, then their tendency to get reduced will be less, and the tendency to get oxidized will be high. Okay, watch out this one carefully and fix in your mind. Next point here, more negative be the standard electrode potential, more be the tendency to get oxidized. Okay, what was the question? Question was, you have to consult this table and will have to find out which can oxidize ferrous ions. That will have to oxidize. That would have to oxidize. Oxidize means itself will reduce. So ferrous ion here, Fe2 plus here, which is above to that, it will have to reduce this ferrous, so it will have to get oxidized. So these elements will have these elements can reduce Fe2 plus into Fe. So any 1, any 3, any 4, whatever we will ask, that you may write. Okay. About the Nernst equation, we will discuss from the next class. That was about the standard electrode potential, what is that? And in the next video, we will discuss about the Nernst equation. The Nernst equation is applicable for the calculation of EMF of a cell when the concentration of electrolyte will be different from 1 molar. Okay, so about that we will discuss in the next video. Okay, it's all for this video. Thank you, Team Educate.